Hello friends, today we will be discussing this new question, and we will be covering an important concept of rolling over a horizontal plane and finding out the maximum friction that is required to keep a cylinder rolling on that horizontal surface. Usually what happens is we assume that the friction is sufficient enough to avoid any kind of sliding. But in this case we are given that the friction might not be sufficient, and at some point the cylinder will start sliding. So we have to find what would be that point at which the cylinder starts sliding, and we have to find the maximum force such that the cylinder does not slide, right? So let's begin with the question. So the question says a uniform solid cylinder of mass m rests on two horizontal planks. A thread is wound on the cylinder. The hanging on end of the thread is pulled vertically down with a constant force F. Find the maximum magnitude of the force F, which still does not bring about any sliding of the cylinder. If the coefficient of friction between the cylinder and the planks is equal to K, what is the acceleration W max of the axis of the cylinder rolling on the inclined plane? Uh, right. So it is basically not the inclined plane, it is a horizontal plane. That might be some mistake in writing, or we can just assume that the inclination is 0, right? Okay. So what we are given is a cylinder is here, and we are applying a constant force F on it, right? This string is wound around it, and this string is constantly pulled with a force of F, and thus it will be exerting a force F on the cylinder, right? So try to imagine what would be the motion of this cylinder, and will it be purely rolling, or will it start sliding after some time? So let's try to imagine that. So as there is friction on this is a rough surface, so there is friction on it, and maximum the coefficient of friction is K, right? So what will happen is, as this force is acting down in downward direction, so it will try to give a angular acceleration to the cylinder. Let's assume it as alpha, right? And as this angular acceleration occurs in this cylinder, then the point that is in contact with the ground will be having a relative motion with the ground. Thus, a friction force will start acting on the cylinder, right? And what would be the direction of this frictional force? So as this point is trying to move in this direction, right? So the friction force would be in the opposite direction, and it would be in this direction. So let's say it is F. So now you can observe that the only force that is acting parallel to the horizontal surface is friction force. So the linear acceleration of the cylinder would be only due to the friction force, right? And there would be no other force which is giving the linear acceleration to this, right? So yeah, and there would be a gravitational force that would be passing through the center of the cylinder. It is neither contributing in the linear acceleration nor in the angular acceleration, right? It is just balancing the normal in this case. Okay. So what we are asked is, we have to find the maximum force F that we can exert on this cylinder such that this friction is capable of keeping the cylinder in pure rolling. Um, that is, it does not allow the cylinder to slide on the surface, right? So yeah. So what will happen if the force is increased above the maximum force that we're talking about? So in that case, what will happen is that friction won't be able to increase the acceleration of the linear acceleration of the cylinder, but the force that we are exerting through the string would be increasing the angular acceleration, right? So in that case, this point that is in contact with the ground will be having some velocity, that I mean that in that case omega r won't be equal to v, where v is the translational velocity and omega is the angular velocity at that point, right? So in that case it will start sliding. So that is quite clear that there would be some point uh, uh, that we should be keeping the maximum force below that. So how to find the maximum force, right? So the idea is simple. We have to write the force equation, the torque equations, and the maximum friction equation, right? So from this FBD, what you can see is what is the normal acting on this cylinder. Normal would be in this direction and in vertically upward direction. So normal value would be equal to, it would be normal would be balanced by the forces in the vertical direction. What are the forces in vertical direction? This is normal mg, and this force, that is tension, or we can say force F, right? These are the forces that are acting in the vertical direction. So normal would be equal to mg plus F, right? So this is our first equation. Now let's write the equation in the horizontal direction. What are the forces acting in the horizontal direction? It is only frictional force that is acting in horizontal direction, and its value would be equal to m into a, where a is the linear acceleration of this cylinder. So this is our second equation, right? What would be our third equation? To write the third equation, I will be writing the torque equation about the center of this cylinder, and what are the forces that are creating torque about this center. First is tension, or the force that we are applying. Another one is frictional force, right? Yeah, these are the two forces that are creating torque about the center, right? So we will be writing the torque equation. We can write F into, and yeah, angular acceleration would be in this direction, obviously, right? So the torque by capital F would be greater than the torque by small f, right? So F into R minus F into R equal to, what is the angle, what is the moment of inertia of the cylinder about the axis? It is equal to m r square by 2, right? Right. So it is equal to m r square by 2 into alpha, right? This would be the torque equation. So F minus F equal to m alpha r by 2. This is our third equation. Now, before it starts sliding, what would be the relation between A and alpha? Now we have to find that, right? As this was not sliding, so it is obvious that the relation between A and alpha would be A equal to alpha r, right? Because this point is at motion, this point is at rest, so its acceleration would be always zero, right? That is the acceleration of the center of the cylinder is A, and its angular acceleration is alpha. So A minus alpha r would be equal to 0. That is the acceleration of this point, A minus alpha, right? It would be always 0. So A equal to alpha r. So we can put this fourth equation in this third equation. So F minus small f is equal to ma by 2, right? And from second equation, F equal to ma. So F equal to 3f by 2, right? So this is one of our result. And what was the now we have to eliminate this f. And how can we eliminate this, right? So before eliminating, let's observe one thing, that capital F is directly proportional to small f, right? This is clearly obvious. And so we have to maximize f. We have to find the maximum value of capital F such that this cylinder does not slide. So to find the maximum value of capital F, we have to apply the maximum friction on the cylinder, and we have to find that critical value, that critical capital F, such that it does not slide. And if we increase the F after that, then it starts sliding. That means the friction won't be able to balance that torque, right? So to find the capital F max, we have to maximize the friction. So 3 by 2 F max, small f max. Now, how to find small f max? We have normal force is equal to mg plus F, capital F, right? So what would be the friction F max? Would be equal to the coefficient of friction K into mg plus F max, right? This would be the equation. This would be the maximum friction force. So substitute this friction force in this equation. F max is equal to 3 by 2 K mg plus F max, right? So from here we can calculate what is the value of F max. F max 2 minus 3K by 2 is equal to 3 by 2 mgk, right? And from here F max is equal to 3 mgk by 2 minus 3k. This is the value of F max. And what we were asked is that what is the maximum acceleration, right? We have to find the omega max, sorry, W max, right? So what would the maximum acceleration? We can find the maximum acceleration from the equation of friction, that is the second equation, F equal to ma. To find friction, what we can do is friction is equal to mg plus F max into coefficient of friction, right? This is maximum friction, and it is equal to m into a max, right? So now let's find what is the value. It would be substituting this F max here, mg plus this would be equal to 2 mg by 2 minus 3k into k by m is equal to a max, right? So a max is equal to 2 gk upon 2 minus 3k, right? So this is the answer, and here we come to the end of the solution. And if you have any doubt in this, then you can join my Telegram group. I have given the link of that in my description. And if and you can also ask any doubt in the comment section as well. If you like the video, you can give a like on this video. And now let's meet in some other video. Okay, bye.